Welcome to part 3 on unique logarithmic behavior. Let's look at the change of base formula. Suppose that you're given a logarithm and you can't calculate it in your calculator because it's not base 10. Most calculators have only two types of log keys, one for common base, base 10, and one for natural log, base e. To evaluate logarithms with any other base, we change the base to e or 10 using the change of base formula. Where, if you have a log base b of x, you can rewrite it as log base a of x over log base a of b. You could also write it this way. Log base b of x would be log natural log of x over natural log of b. And you'll get the same answer either way. So let's use this formula to approximate a logarithmic function by calculator. We have log base 4 of 30. We can rewrite this as something to calculate in your calculator as log of 30 over log of 4. Now, I hesitate to just leave you with this. It seems kind of strange, and it may be kind of difficult to remember how to keep this change of base formula in your head. But the way I remember it is I'm breaking my change of base into two pieces. I have a log in the numerator, and I have a log in the denominator. And the numerator's log is the upper number, the bigger, higher number in the log base 4 of 30. And the base is the number that's lower, and it goes in the denominator. So if you have a change of base situation that needs to happen, you can just remember that the number that you put in the numerator is the one that's a little bit higher, and the one you put in the denominator is a little bit lower. I don't know if it helps you. If it does, awesome. If it doesn't, disregard. So let's calculate this. We've got just log. We've got log of 30 divided by log of 4. And we get 2.45, rounding to 2 decimal places. Now let's try log base 2 of 14. That will be log of 14 over log of 2. This will be approximately, let's find out. Log of 14. Make sure to close your parentheses because we're not dividing 14 by 2. That will give you something completely different. Log of 2. This is approximately 3.81. Note that log of 14 divided by log of 2 is not the same as, or does not equal, log of 14 divided by 2. Don't do that. That's completely wrong. But it is worth noting because I do see it happen on occasion. Let's graph f of x equals log base 5 of x plus 1 minus 2 in your calculator. And then let's find the domain of this function. Putting this in the y equals, we'll have log Now, what am I going to do because log base 10 is the default? Well, I can write this as a change of base. So before I enter it in the calculator, I can write this as log base 10 of x plus 1, and I don't even have to write the base 10, but just for emphasis, over log base 10 of 5 minus 2. So we'll go ahead and enter that in our calculator. So it's assumed to be base 10, so we don't have to write that in there. X plus 1 in the numerator divided by log of 5 in the denominator, and then minus 2. Let's graph that and see what happens. Now you could have probably figured out that this should be the behavior of the function just by transformations, because log base 5 of any value, log base 5 of x, the generic version, is similar in shape. So we know that our function must be positive, so x plus 1 must be greater than 0, and therefore x must be greater than negative 1. So the domain of this function exists, open paren, negative 1, comma, to infinity, close parenthesis. Now, let's talk about how this is graphed. We know that our vertical asymptote exists at negative 1, and we know it's been shifted down 2. So our curve approaches the vertical asymptote. We know if it's been shifted down 2 and our vertical asymptote is at negative 1, we know that it would normally cross at 1, so it's going to cross at 0, negative 2, and it's going to curve up like this. And we get a function something like this, where the domain is from negative 1, not including 1, negative 1, because it is a vertical asymptote at that point, all the way to positive infinity. So I hope this helps with logarithms, and now it's up to you to just practice them.